Well, good morning, all. Let's take a look at this problem that we were working on yesterday. I'll show you some of the common mistakes. Um, Most of you did this. We looked at this beginning piece, and we made the assumption that the large one goes all the way to the floor. But if you read in the problem, it says they're going 2.2 meters per second as they pass. That means here in the middle. So we have to define this 0 point. We define the floor as 0. Then the before picture, the mass is 56 centimeters above the floor. In the after picture, they're both 28 centimeters off of the floor. So in the before, there's only potential energy of this guy. After, they're both moving, so they both have kinetic energy, and they both have potential. So let's look at the equation. Let me move this guy up here out of the way quick. And here's the equation. The potential energy before equals the potential energy after of this one, potential energy of the other one after, and they both have kinetic energy because they're moving. I'm using these little prime symbols to indicate after, and potential energy before does not have a prime, it's before. When we fill in what we know, each one is mgh for potential energy, 1/2 mv squared for the kinetic energies. And here's a step that a lot of us struggled with. We're looking for mass 2. So I need to get all the terms that have mass 2 on one side. So here they are, mass 2, mass 2. I moved all the terms that have m1 to the other side. Then we, of course, use the distributive rule. We're going to pull out m1 on this side. We're going to pull out m2 on this side. And the last step is to divide both sides by this thing in parentheses. And then, of course, we plug in some numbers. We find out that it's 6.9 grams. Now, you have to be careful with your units. I notice here it was given as 56 centimeters. In order for this to work out, we do need to convert that to meters. We don't need to convert grams because we actually want grams in our answer. So if you investigate the units here, everything cancels out except for grams. So we can just leave that and we end up with 6.9. Now, I thought 6.9 was kind of small compared to the 110. So I thought, let's check this using something we know from the past. So I went back and I did this. I remember the old Atwood's device equation for acceleration based on the masses. And so I calculated quick. The acceleration is 8.64 meters per second squared. And then, of course, I used the fourth kinematic equation to find the final velocity. The initial velocity was 0, right? It went from rest. And I found out that at the end, it's going 2.2 meters per second, which agrees with what was given in the problem. I'll send this out. I'll also attach the PowerPoint so you can take a look at this solution. Hopefully that helps out. And I hope you guys are doing well.